Were you married by that time?
Yes. I suppose it's partly because my marriage was breaking up, and I've had some more links back in Cambridge. And the funny thing about American, I think, society in general is that you don't. I mean, all my links with people here are almost all long-lasting, quite sort of deep in a sense, so superficial in another, but in other senses. Whereas in America, it's all changing and reflected very much in sort of the average time a person lives in a particular place is about 2 years or something in America, whereas here it tends to be more like 200. So desire to get back to and my mother was old and dying and so on, you know. And a very nice job. Your total responsibilities are really confined to writing a 200-word summary of your activities during a year or something. You can do other stuff if you like.
What was the job?
I was a Royal Society research professor.
Ah, that's very distinguished and very, as you say, heaven on earth. I mean,
yes.
Robert Hind was one as well.
Yes, he was. Yes, that's right.
A wonderful job. Just do what you like. Yes, and it's for life, isn't it?
It was, but I was one of the last ones. I think they've now changed it. I don't think. I think you're right to change it in the sense I don't think it's really. If you want to make the best use of these people, you shouldn't have them appoint them for life. People aren't like that.
Yeah.
That's what they.
You wrote several seminal papers around this period, according to the sources I've seen. If you had to, as you are having to, summarize what you think are your most important ideas briefly, and contributions, how would you describe them?
Well, in sort of confining it to neurophysiology, I was one of the first people to realize how much and the type of analysis that has to go on early in vision in order for us to be able to see as we do, and particularly with regard to the statistical aspects of vision, the fact that we infer so much from so little and things like that, is because we already have learnt so much of the statistical facts. We don't reckon these are not things that we can say exactly what we've learned, but we know that if you drop a penny, if you let go of a penny, it drops, and all the sort of facts about the environment and about the world in general behaves around us. We already have expectations formed, and it's because of those expectations that we can predict as well as we can. This is a principle that goes right through perception and cognition and so on. And I think this was not the way people thought of the brain when I started off in the 1940s, but it is very much the way that people think of the brain now. And
how early in life does this occur? Because there used to be theories among psychologists and so on that I've forgotten a very famous psychologist who worked on child learning and
Piaget.
Piaget, that it took quite a long time before you could infants recognise patterns and so on and so on.
Well, yes, he would be talking about high order patterns. What I'm talking about is things that are very, very elementary level, down to in fact one of the first things that sort of brought out how extremely sensitive the eye is in this regard, concern the actual detection of single quanta of light and so on, that you can actually get down to the graininess of the light itself limits your perception under a wide variety of circumstances. So you've got to have an efficient statistical machinery there, otherwise you won't be able to do it. So some things become impossible unless you have the statistically efficient mechanisms around for determining what's associated with what. And this is a very much a pre-Piagetian level, and of course it goes on. Well, I don't know when it stops, and well, actually, I think I am beginning to be aware when it stops.
I mean, you're talking here about the way in which you generate a lot of information from a small amount of information.
Well, you can't generate information.
No, but
so
you extrapolate or...
Yes, or you interpolate.
Interpolate.
Yes.
But you also did work at the other end, which is how you delete to make things... I mean, delete redundancies, and you don't need as much information as that. You can...
When some information is permanent, you don't need to meddle with that. You use it to find out what's up to date. But the redundancy reduction has often been misinterpreted, because it's not. It's what you're really doing. You're using the redundancy that you've learnt about, that you've acquired knowledge of, in order to understand better what's going on now. And I think this is and it's the only definition of intelligence that makes sense to me, at least, is this process of using the statistical regularities that you detect in order to make inferences about the present and past, and in some cases the future. But you have to. There's a very big difference in the way of thinking about these statistics now, and was prevalent when I was at school. I wasn't taught any statistics at school that I can recall. Whereas now, I mean, it's an important part of anybody's education.
Do you think I don't know whether your work has directly, but it must have indirectly affected a lot of work that's been done in film and computers and so on, whereby they've worked out how to sample visual images so that you can just take cross sections and then create a full picture, but by only sampling at 1/25th of a second or whatever it is. And with recent decompression algorithms in computing, you can actually compress a huge amount of information into quite a small set of digital signals, which will then decompress and human beings can see it. Do you think your work was related to this?
Yes, well, I was very lucky when I was both up here and later when I was working in London, in knowing people like Tommy Gold up here and others who understood the statistical aspects of information, and David McLeod, not David McLeod, not McLeod, Mackay, Donald Mackay, and who was a student of Dennis Gabor, who understood all the statistical principles here, but they're not rather few people even now understand information theory and what redundancy is and isn't. But I think it has a completely revolutionary effect on how one looks at what the brain is doing all the time. And you can't create new information. That's like saying, spontaneous combustion, all things. Statistical mechanics shows is impossible. But what you can do is filter. And the fact, the sort of fact about the world, which is missing from earlier views, is what an enormous amount of regularity there is. If you take any object or state of affairs, it's going to be almost exactly the same an instant later, and all that stuff which is the same, there isn't any statistics to it. That's
how they do the sampling of film, isn't it? They just note the changes, and save the changes.
Yes. But the other aspect, which I think is much more illuminating, is if you look at language, that if you take the number of words in the English language, it's what, 500,000 or something, but if you take it only needs whatever, I can't do the sum in my head, but it only needs you have to be very careful how you say these things, because they mean something totally different if you don't get it exactly right. But the fact of the matter is, if you've taken a random assembly of letters, it doesn't make a word or a sentence at all, because there are so many possible arrangements of those letters which mean nothing at all, that don't happen, can't happen. And the same is true of the images. That, if you take pure random noise and record it on film, you can't see anything there. It's a rainstorm, it's a snowstorm, it's a completely meaningless. So that the only thing one sees in an image are the statistical regularities. That not only are that in one single frame you don't get very much, but if you get sequences of frames, there's a lot that's shared between them, and those are the things you see. Just as if things are arranged in a line, you detect the line immediately. But if they lack that patterned element, you don't see the line. So what one's seeing, to say that you remove redundancy is the reverse of the truth, in a sense. The redundancy is what you see. That's what composes your images. And this has been a change that's, you can find elements of it in the thinking of people like Ernst Mach and Helmholtz and so on. But really only traces of that. And so it wasn't until post-war, post-Second War, that the full significance of information theory for understanding the brain appeared, because people didn't really appreciate this fact about language and about all our senses. They are actually composed of redundant features in the images. This is what we use. It's economy of thought was one of the earlier. So you can find traces of this thinking going back to the to the 19th century, but this has sort of come to fruition with development of cybernetic devices, which is why it's taken. Even the people most deeply involved in it, people who first tried to do computer pattern recognition, didn't really fully appreciate the significance of this as far as perception was concerned. And so having been tutored, so to speak, by people like Tommy Gold and Donald Mackay and others. I reckon I'm one of the earliest generation of people interested in psychology who have understood the full significance of this.
What was your early work on frogs' brains?
It was Frog's Eyes.
Frog's Eyes, yes.
Well, why I wanted to go into it in the first place was that the early work, which was, I mentioned Hartline earlier, had done on frogs' vision, had shown that there were 4 different types of ganglion cell. We now appreciate that there are closer to 400 types, and they're each telling the brain something different and something about a much larger element of what is coming into the brain. It's talking about a pattern in a particular region. And the simplest example of this is motion. I think it's true to say that even though there were lots of the illusions and so on associated with motion, have been known since the 19th century. But the fact that what's crucial from modern understanding of the subject is that motion is one of the simplest type of patterns we detect. But you can't have motion without knowledge at 2 different places, positions in time and space, because that's what motion tells you, is that this has changed, that there's been a coordinate change of position and time of occurrence. And this is one of the simplest types of thing that you can use to simply, once you've got a signal for motion, rather than separate occurrence of things at 2 different times and places, then you can get joint motion of different parts. So you can see that the whole eye is moving, and you can see that it brings you, it expands the alphabet that you can use in information theory terms. And it's clear from the kind of things that we do use to express our subjective experience are very complex elements of this time. I don't think I've done a very good job of simplifying this, but of making it clear. But I still think it's really rather unappreciated how much and how significant it is. So I think I'm very lucky in having lived and worked in this time, because it's such an important principle, and it applies to so much of perception. And it's the same as what applies, and people have appreciated when you're talking about a major complex incident. This has got to be made up. You can't make that up out of well, I shouldn't have said that, because it's just the fact that you can make that up by the joint occurrence, as a joint occurrence of many different little events, and what kind of. But when you do so, you've got to have joint occurrence of little events, which both has occurred and also occurs, is something that occurs frequently. If you can't have a concept. There's no such thing as a simple concept, because they've always got to be made up of lots of little events. And it's how these are detected that is the problem of perception and cognition and so on.
There were two last questions I wanted to ask you particularly. One is about how you worked or work. I don't know whether you're of the Eureka brigade of scientists who, remembers the moment when you suddenly, one of your major ideas came to you, or whether it was just a gradual growth. But if you're of the Eureka type, then are there particular occasions? Is it when you're walking? Is it when you're listening to music? Is it when you're having a shower? Is it when you're drinking wine and talking to someone at a table? What are the contexts where you find the more important ideas flow?
Well, I think a lot to myself, if you see what I mean, and I think having a bath or just lying in bed,
relaxing.
Yes, spend a lot of time thinking trying to get. It's always trying to see relations where you haven't seen them and see, good heavens, that also applies here, doesn't it? Oh, yes, and that rather similar to what happens here. So you get sort of fields of similarity and.
And these happen not when you're at your lab desk, so to speak, but in moments of relaxation and.
I think so, yes. I think more. I mean, I suppose it's a novelty. If it's new, there's got to be a moment when it became new. And that tends to be when you're not doing anything else, I think.
The other question is about religion. I often ask people about this when they're at their boarding schools at Winchester and they're being confirmed and things like this. But we missed that time in your life. Has religion ever been important to you? Is it important to you?
No, it's not important to me. I mean, in the sense that, not only do I not believe, I mean, it's not. It always seems to be if saying you don't believe in God is a very foolish thing to say, because,
yes.
Why do so many people talk about it? But that can't be right. There's got to be more to it than that. So I think one has to respect some of the things that godly people say, and even some of the things they do. So I don't have a lack of respect for religion.
You're not a Richard Dawkins.
No. I think it's just foolish. I mean, if you say, well, I don't particularly want. Well, I wish one could make more sense of it, of that aspect of it. But I don't think the godly people have done a very good job, as far as I can see.
You've never, I mean, you were confirmed.
No, I wasn't, no. I was never baptised or confirmed.
Really? So you've never been a practitioner of religion, really?
No. And I don't miss it, I don't think, very much.
Do you think science has disproved religion, as Dawkins argues?
I think it provides some hope of acting more rationally to handle the social and political problems that we have to deal with, both on a personal level and on a worldwide level. I think if you regard religion as a way of perpetuating a way of thought that might otherwise have been lost, I think that's fine.